Today, let's talk about the neuroanatomy, the elementary introduction. This is part 1. I'm from Department of Neurosurgery, Qilu Hospital and Shandong University. Neurosurgery has a long history, and there is a lot of evidence that suggested that the ancients were starting to get a sense of human skull and try to figure it out. The world's earliest record was France has been verified more than 7,000 years ago, and China's earliest record was the Guangzhou County top. This county is just in our Shandong province. It's more than 5,000 years ago. In ancient Egypt, the brain tissue was removed from the nasal cavity. The people at that time, they want to make mummy, and they also try to keep the skull intact. So they find out that the nasal cavity is connected with the gall cavity. So they try to remove the brain from the nasal cavity. In 20th century, under the guidance of Cushing, Dandy, Moniz, who invented the cerebral angiography, and Horsfield, who invented the CT scan, and Yasagio, who developed the microscope in the neurosurgery, and other pioneers. The neurosurgery has from the gross neurosurgery to minimal invasive neurosurgery. The people try to see the brain and the structures more and more clear. Of course, the development of the neurosurgery is inseparable from the progress of surgical equipment, which allows us to magnify the field of surgery, illuminate it better, and see it more clear, and has less trauma to the patient. This is a basic step of neurosurgery operations. If we want to try to understand the neuroanatomy, we also need to know the steps just in the figures. The first figure is we're going to mark a decision and draft. After we sterilized the surgical field, we're going to cut the skin and expose the subcutaneous and the muscle, and expose the skull. We're going to burn a hole in the skull and remove the bone. Of course, we're going to keep the bone, and after the surgery, we're going to replace the bone. After we open the dural, we can see the brain just here, and we elevated the brain. We can see the tumor. We're going to do the neurosurgical operations after we elevated the brain. After we're going to resect the tumors, and we're going to suture the dural and replace the bone and suture the skin. It's just like this is a basic step of neurosurgical operations. Neuroanatomy is a branch of anatomy that studies the anatomic organization of nervous system. The human nervous system is divided into the central and peripheral nervous system. The central nervous system consists of brain and spinal cord and play a key role in controlling behaviors. And the peripheral nervous system is made up of the neurons in the body outside the central nervous system. It is further divided into somatic and automatic nervous system. The somatic nervous system is made up of afferent neurons that convey sensory information from the sensor organs spinal cord. The efferent neurons that carry motor instructions to the muscle. The automatic nervous system has also two subdivisions. The sympathetic nervous system is a set of nerves that activate what has been called the fight or flight response that prepares the body for action. The parasympathetic nervous system instead prepares the body to rest and conserve energy. The central nervous system represents the largest part of the nervous system, including the brain and spinal cord. Together with the peripheral nervous system, it has a fundamental role of the control of behaviors. The CNS is consistent within the dorsal cavity with the brain within the cranial subcavity and the spinal cord in the spinal cavity. And the brain can be divided into this part. The first one is the telencephalon, and the second is the dicephalon, and the cerebellum, midbrain, pons, and medulla oblongata, and also the spinal cord here. The cerebral cortex represents the highest central for sensory and motor processing. In general, the frontal lobe processes motor, visual, speech, personality modalities, and the parietal lobe processes the sensory information, and the temporal lobe auditory and memory modalities, and the occipital lobe which controls the vision. The cerebellum coordinates the smooth motor activities and processes muscle position, and the brainstem, which consists of medulla, pons, midbrain, conveys motor and sensory information and mediates the important automatic functions. And the spinal cord receives the sensory input from the body and conveys somatic and autosomatic motor information to peripheral targets such as muscles and visceral. The telencephalon is a technical name for a large region within the brain, which is contributed to many functions, which some groups would class as unique feature, which makes the human stand out from other species. Many people refer to it as the cerebellum, but due to the naming conventions of organs, it is technically refer it as a telencephalon. The lobes of cerebral cortex include the frontal, temporal, occipital, and parietal lobe. As a more technical definition, the telencephalon refers to the cerebral hemisphere and other smaller structures within the brain. Despite the fact that the telencephalon is one of the larger division, the term is technically anterior-most embryological division of the brain that developed from the postcenphal. This is the telencephalon under microscope. When we do our neurosurgery, we always try to protect the normal brain tissues. And in the red pictures, we can see the frontal lobe is like this one. And in the left pictures, we can see the frontal lobe and the temporal lobe. We can see on the surface of the brain, we can see some vessels, and we can see the cell fissure and the gyros here and the sulcus subdates the different gyros. Motor cortex movement is central to the primary motor cortex of the brain, which sends message to the muscle via the brainstem and the spinal cord. The motor cortex is particularly important and the complex movements and not the basic actions such as coughing, crying, and giggling. Within the motor cortex, there are areas which control the specific part of the bodies. The diagram illustrates the approximate position of neurons designated to specific area of the body. Note that there is no relationship between the size of the area of the body and the number of neurons involved. This is due to the complexity of movement in the area dictating how many neurons are needed. For example, although the trunk is a large area of the body, does not need to complete the complex movement, just twisting and bending, so therefore it does not need much more brain to control it. The primary visual context is very important. The brain has two visual contexts, one in each hemisphere. The primary visual context is in the occipital lobe, which is at the leg of the brain. There is an area within it called V1, which seems to be necessary for visual perception. People which damage to that area report no visual of any kind. The visual information was transmitted along two pathways, one containing the components of the visual field and the other being involved in the location within the visual field. Somatosensory center. Somatosensory is referring to the sensation of the body. The somatosensory context lies next to the motor context in the brain. It preserves touch, so the amount of neurons connections need to be detected, the amount of the somatic sensory context needed for that area of the body. Speech and language are mainly attributed to the part of the cerebral cortex, which is one portion of the tetracephalon. Motor portion of the language are attributed to the Broca area within the frontal lobe. Speech comprehension attributed to the Wernicke's area, which lies to the temporal parietal lobe junction. These two regions are interconnected by a large white matter tract known as the acute facilities. The Broca works therefore correctly identifies the area of the brain responsible for speech production. Not all words are affected equally in this area of the brain. Nouns and verbs seem to relatively affect some patients with damage in the Broca area, but other classes of words such as the prepositions and the conjunctions cannot be spoken. Wernicke's area is another area. There is a separate area of language processing which seems to have the specific functions. In 1874, Carl Wernicke, who worked at a hospital in Germany, found that the patient who had damage in this area close to the auditory context and the specific language impairment. This includes the inability to comprehend the language and the anomia, which was someone's struggle to find the words they need. The Wernicke noticed that the people did have the fluent speech. When they could access a word quickly, this led Wernicke's areas was important for understanding the accessing words. If the lesion in the patient's brain affected the functional area, such as this lesion is just in the motor area of the patient, we can do awakening anesthesia for treatment of gliomas in or near the motor areas. We can see the patient was under the neurosurgical operation. They are awake. During the operation, we can let the people move their hands, move their foot, and speak something. We can make sure that the function of the patient is intact. We have finished the part 1 of neuroanatomy elementary introduction. Thank you.